Hello, my friends in Choueifat school. This is Wael Bashuri, math and physics teacher. In this video, I'm going to solve this physics quiz online for periodic grade 9. So let's directly start reading first question. Choose the correct answer that completes the sentence below. So light that has one color is called monochromatic. Monochromatic light means light of one wave and one color. Question number 2. An object is placed in front of a converging lens at a distance equal to twice the focal length as shown. What are the properties of the image formed by the lens? So here, in order to know the properties, let us first draw the position and the position of the image and the image itself. So we take a parallel ray from here. This ray will convert passing through the focus of the lens like this. And then we take another ray from the optical center, and this one will continue without refraction. Will continue undeviated. Now where the image is formed is where the rays meet. So here we draw the image descriptions, inverted, same size as the object, same length, and real. Real because if you put a screen here, you can receive it on a screen. So you have to choose inverted, real, and same length as the object. So here you have inverted, same size, and since you don't have real, so these are the only two options available. If there is another option which is real, you have to choose it. But here we don't have. Number 3 now. An object of height 4 centimeters is placed 30 centimeters in front of a converging lens whose focal length is 10. The image formed is located 15 centimeters from the lens. Which of the following is true? So let's quickly draw the diagram. Here you have the focal length, which is 10 centimeters. And here you have the first focus. And here you place the object at 30 centimeters from the lens. So this is 30 from the lens. And we are told in the question that the image is formed 15 centimeters from the lens. So here it's 15. As we did in the previous question, we draw like this, then we have to draw the image at a distance of 15 from the lens. So this is 15. Since the distance from the lens is 15, it's half the distance of the object, the image would be diminished and it would be half the size of the object because the distance 15 is half of 30. And it will be real and inverted. So now let's choose the correct options. The height of the image must be 2. It is half of 4, as we said. The image is real and inverted. The image is diminished. Number 4. The refractive index of air is 1 and diamond is 2.4. The critical angle for diamond air boundary, what is it? Now, to find the critical angle, we can say in this case, refractive index is 1 over sine critical angle. And then refractive index is 2.4 is equal to 1 over sine critical angle. Now you cross multiply and rearrange. So you get sine C is equal to 1 over 2.4. Now, to find the critical angle, we can say C is equal to sine inverse 1 over 2.4. On the calculator, you get the critical angle. Question number 5 now. The light ray in the diagram below hits the glass air boundary at an angle greater than critical angle. Select the diagram that correctly describes the subsequent behavior of the light ray. So here the keyword is greater than critical angle. So when this comes at the greater than critical angle, it will refract it will not refract, it will be totally internally reflected, like this. So this is total internal reflection, TIR. So here you choose the option that represents total internal reflection. Question number 6 now. The diagram below shows dispersion of white light through a glass prism. Which color bends the most? Choose the correct option. Okay, the color that bends the most will be violet here, because it has greatest refractive index. Which color travels slowest through glass? Also, slowest through glass will be also violet. So here we choose violet. Which color has the lowest refractive index? Lowest refractive index is red. Number 7. A parallel beam of light is incident on a converging lens as shown. How will the beam light continue after the lens? So here all the rays that are parallel will refract through the focus. So this will refract through the focus. This will refract through the focus. This one same thing. And this one same thing. So here you have to choose it passes through the focus. Question 8 now. Choose the correct term to its corresponding description. The point on the principal axis through which rays parallel to the principal axis refract passing through it or appear to come from is called the principal focus. The focus. So all paraxial rays will refract through the focus. The distance between the optical center and the principal focus is called focal length. Number 9. Principal focus F of a converging lens is shown below. The distance between the lens and F is the focal length, and the distance between the lens and 2F is twice the focal length. Where should we place an object to produce a real image? Choose the correct answer. To produce a real image, let me show you the options. Here it can produce a real image. Here it can produce a real image. And here it can produce a real image. While between the optical center and the focus, it can produce a virtual image. And if you put it exactly at F, which means here, no image is formed. So here we see between F and the optical center, no. At F exactly as we said, no image. At a distance beyond F, we choose this one. Question number 10. The image formed by a converging lens is shown below. Which of the following statements describing the ray diagram is true? Okay, the image here is virtual upright, as you can see, and you can only see it from Q. So the image is upright, it's not inverted, also virtual, and can be seen through Q. So now we choose these options. The image can only be seen by P, no. The lens is being used as magnifying glass, yes, you can see this. The image has become larger in size. And then the image formed between the focal length and the lens, no. The image can be seen through Q, yes. The image is upright. Okay. Next question, number 11. A penny dropped into a pool, refractive index 1.33, appears to be 1.60 meters deep. The real depth of the pool is to 2 decimal places is. Now here you have the formula refractive index equal real depth over apparent depth. So refractive index is 1.33 is equal to real depth. That's what we have to find. We don't know it. So Real depth, we don't know it. Apparent depth, we have it 1.60. So now if you cross multiply, real equal 1.60 times 1.33. Question number 12. A ray of yellow light is incident at the prism shown below. At point O, the ray bends inside the prism, then leaves it and hits the screen at point Y. Choose the correct answer to complete the sentence. If a ray of red light is incident at the same angle at the same point O as yellow ray, then the red spot on the screen will be above. Because remember, when the white light comes like this, it will disperse, giving you Roy G. Bev. Roy G. Bev. Red, orange, yellow, green, blue, indigo, violet. You can notice easily that the red is at the top, violet is at the bottom, and then the other colors is in between. So here clearly red must be at the top. So that's why we have choose above Y. The dependence of speed of light in matter on color of light is phenomenon called dispersion. Number 13. Based on its shape, this lens is what type? Now this is a divergent lens because it's concave. Okay, so this is concave divergent. Next one, number 14. An incident ray of light in glass hits the boundary with air. What happens to the ray when its angle of incidence is less than critical angle at a glass air interface? Less than critical angle, it propagates, it refracts away from the normal. What happens to the ray of light when its angle of incidence is greater than a critical angle at glass air boundary? In this case, it will undergo total internal reflection. Next question. Figure below shows a ray of light incident from air into a block of ice at point A. The critical angle at the ice-air interface is around 50. Select the figure that shows the propagation of ray from point B until it leaves the glass. We are told that the critical angle is 50. Now here we draw the normal. Here we draw the normal and see this angle must be 60 because the normal makes angle 90 with the surface. This comes at an angle 60 greater than 50, the critical angle. It will do total internal reflection. So like this, total internal reflection. Here again we draw the normal. That's the normal. And then we calculate. If this angle is 60, this is 60, and this is 30, because this angle is 90. So this angle here will be 60, and this angle here will be 30. Now, when it hits at angle 30, this is less than critical angle, it will refract away from the normal. And like this. So that's what we have to choose. That's the option we have to choose, which is this one. The refractive index of the ice block to 1 decimal place. Refractive index is equal to 1 over sine critical angle. So n equal 1 over sine c. We are told in the question that critical angle is 50. So sine 50. 1 over sine 50 equal to refractive index. Question 15 now. A beam of light strikes the interface between water, refractive index 1.33, and air at an angle of incidence 40 is shown below. Select the ray diagram that shows the correct propagation of the incident ray. So here it comes at an angle 40. It comes from water to air at an angle 40. Now this will refract away from the normal. So we have to choose this option. Part of the ray will be reflected and part will be refracted away from the normal. No, I have to choose this option, refraction away from the normal and reflection. So the angle of reflection is 40. The angle of refraction, we have to calculate it. How do you calculate angle of refraction? By Snell's law. So this is 40 n1. So here you have to say n1 sine 40 equal n2 sine r. So n1 is given to us here, water, 1.33 times sine 40 equals n2, it's air, it's always 1, times sine r. Now you multiply these and you do shift sign. So r will be equal to sine inverse this amount, 1.33 times sine 40. Put it like this on the calculator, you get the angle of refraction. Next question. At what angles range would the beam of light not propagate through air? Choose the correct answer. Not propagate through air means it will do total internal reflection, like this. And this happens only when the angle I greater than critical angle. So you have to choose the option which has greater than critical angle. So now, after calculating critical angle in question II, we have to see the options. We have to choose greater than 49 because the critical angle here is almost 48 or 49 to one decimal place or to nearest whole number 49. So any ray of light greater than 49 will do total internal reflection. Okay, the rest of the questions we can continue or complete them in a different video. Thank you very much indeed for watching.